Hi, I'm Rahal from Vivo Asia, and today I'm going to explain factors affecting Wi-Fi performance when performing a coverage study. And today I'm going to show you and explain how exactly different factors affect Wi-Fi performance using the sample layout I have here of a typical living quarters of a vessel. So these are a variety of different materials with, we have metal doors as well that we need to worry about. So it's not just the wall material. All of these materials will affect how Wi-Fi propagates. So signal would pass through some materials almost like they didn't exist in a way, but some would stop Wi-Fi signals right in their tracks. Partition materials that are used in vessels and also in other areas like offices and also homes. They are reasonable, like they are pretty reasonable in their transmission of Wi-Fi signals compared to something such as metal or concrete. Wi-Fi performs pretty poorly if it has to pass through concrete or metal. As you can see with the result of our simulation on our color-coded heat map, the signal strength is generally varying about 50 to 51 decibels inside our room. So it has pretty good transmissibility of 2.4 GHz spectrum, um, as opposed to something like metal, as we saw in our 3D view of this simulation. The area right behind the access point has metal inside the walls, has a metal partition inside the walls. And that stops the wireless signal from propagating right in its tracks. There's no way it's getting through that. So having a good understanding of this is pretty important with placement. As you can see on screen, the Wi-Fi signal from this access point propagates through this partition board pretty well, but it's stopped by this particular wall right here. You can put it right up to it and we'll still see the same result. Yes, as you can see, it passes right through the partition pretty well, but it's stopped by the metal. So it's important when considering placement. Generally, because it's a bit unpredictable on how the rooms would be, we generally like to place the access point in hallways for that reason. Hallways provide a much better spread of Wi-Fi signals. So as we can see, we are getting about 50 to 55 dB, which is pretty good because generally about 67 is regarded as a good standard of Wi-Fi. So in this configuration, it's not impeded too much by any metal walls because we placed it in between the wall, so it can just pass pretty well through partitioning boards. So normally we don't have one access point, we have quite a few. So we can, based on that, we can design it accordingly. And we create a pretty good spread. Generally, another reason we keep our access points in the hallways is to do it obstructions, right? When placing a access point in a room uh, generally puts it at a disadvantage because it has to pass through walls, more and more walls to get to the next room. So for example, if you place the access point over here, it has to pass through this wall and this wall to get to this room, which is not practical because it'll attenuate quite a bit by that point. But if you place it in the corridor, generally speaking, it is a bit more unimpeded from either side as it has to pass through less layers. And it's also not going to be affected too much by the furniture and other structural components. So we can have, as I mentioned, furniture, then also things like bedding, and people moving around inside as well. So it will be a pretty less affected by that category. Another important factor which is related to obstacles itself is the mounting height of the access point. Mounting height is pretty important because it gives greater line of sight around obstacles if the AFE is mounted closer to the ceiling. Generally, it's a pretty terrible idea to mount an access point at floor level because all the furniture, people's movements would give it pretty bad line of sight with devices such as laptops, smartphones, and other Wi-Fi endpoints. It's pretty important to make sure that our access point is mounted as high as possible so that we get that coverage. So when I increase the height extremely close to the ceiling. So in this simulation, the ceiling height is set at 3 meters based on the specification of this floor. And if we change it to 2.9 meters, which is extremely close to the ceiling, we see we have much more even coverage, much better coverage. Some other factors that are important to bring up are also where exactly the access point is placed in respect to objects that may cause interference. A good example is in a ship's galley, you may get microwaves. Microwaves are a relatively source of interference for most access points sometimes. So placing an access point near a microwave or some other high RF device is generally a bad idea, as the interference will definitely reduce performance of the system. So those are some other non-material considerations that also need to take into account. Also, water is also a pretty good absorber of RF signals, and Wi-Fi is absorbed pretty well by water. So placing it near, let's say you have some sort of tank, a water tank, or even a fish tank, it's a bad idea to put your access points close to that because it will be absorbed and attenuated by the water itself. So those are some considerations that we at Vivo Asia make when we design optimal AP placement.